Hello everyone, now we are going to solve the next question of GATE 2016. The system shown in figure consists of a block A of mass m 5 kg connected to a spring through a massless rope passing over a pulley B of radius r and the mass 20 kilograms. So there is a mass of pulley, that is 20 kilogram, and the mass of the block is 5 kilogram. Okay, the spring constant K value is given, that is 1500 Newton per meter. If there is no slipping of the rope over the pulley, the natural frequency of the system. So we can apply torque method. It is easy. Just you just have to write down the equations. So if you apply the torque method, you have to consider. You just have to provide some angular displacement, small angular displacement to this pulley, like that, theta. Okay, either you can provide angular displacement in that direction or in that directions, it doesn't matter. So here will be I theta double dot, that is the inertial torque, and the spring force torque would be also be considered here. So that is K. What is the displacement? Suppose this is the angular displacement theta, so this would be the displacement of the spring equal to that, and that means it is r theta. Okay, and we are considering torque about point O. This is the hinged point. Okay, so we are considering the torque about point O, so that would be r. Okay, this is the spring force, and this is multiplication with r, that consists of torque. Okay, so we just have to write down the equations, that is I theta double dot plus k r square theta equal to 0. So this is the equations of vibrations. We have to rearrange these equations. So theta double dot plus k r square upon I theta is equal to 0. We know that this term represent omega n square, so omega n square becomes k r square upon I, but we have not calculated moment of inertia yet, so we will calculate I is equal to, we know that moment of inertia L for the disk, pulley is a disk. Okay, so for the disk is mr square by 2. Okay, this is mr square by 2, but here there is a mass which is going to be attached here with the rope, so it also consider, if this is capital M, this is small m, mr square. Okay, so this mass is 20 kilogram, r square by 2, and this is 5 r square, so you will get 15 r square. That is the moment of inertia. Okay, 15 r square. We just have to put this value here. So omega n would be equal to under root of k r square. K r square upon I is 15 r square. This would be cancelled out, and k value is given, that is 1500 Newton per meter. So 1500 upon 15, and you will get the omega n, that would be 10 radian per second. So the answer is 10 radian per second. Okay, we just have to apply the torque method. This is easy. You just have to write down the equations and everything is going to be solved. So I hope you will understand the solution of that question. Okay.